All right, so today we're going to talk about molar mass, and molar mass is going to be one of the most important calculations that we do throughout the year. We will use this from now until the end of the year, and it's just going to be assumed that you know how to do molar mass. It's very easy. If you can add and multiply, you can do this, okay? So it's really, really easy. But first of all, let's kind of tell you what a mole is, okay? It is the SI unit for the amount of substance. So we talked about SI units in the measurement unit, and we only listed some of them, but if for the amount of substance, mole is the accepted SI unit. A mole is actually the amount of a substance that contains as many particles as atoms in exactly 12 grams. And do you want to guess what element I'm going to say? Carbon 12, because we said that's what it's based on. So exactly 12 grams of carbon 12, how many atoms is that? It is a counting unit, so there are going to be some things that we need to recognize. You can have a mole of atoms, and we talk about atoms when we're referring to elements. So you could have 6.022 times 10 to the 23rd atoms of copper. We talk about molecules, and molecules, when we get further in the year, you'll find out is for covalently bonded to nonmetals. So I could have a mole of water molecules, which would be 6.022 times 10 to the 23rd molecules. I can have ions, and I can have also formula units. And formula units are something that we use for ionic compounds, is when a metal and a nonmetal are combined. So if I had sodium chloride, I could say I have 6.022 times 10 to the 23rd formula units in 1 mole of sodium chloride. Okay? So between the song and me saying it about 4 times right now, the number for a mole of anything is 6.022 times 10 to the 23rd. Okay? What that means is that 12 grams of carbon 12 contain 6.022 times 10 to the 23rd atoms of carbon. Okay? It is a counting unit. Okay? If I say I have a dozen donuts, how many donuts do I have? 12. If I have a dozen cookies, how many cookies do I have? How about a dozen eggs? No matter what I have a dozen of, a dozen means 12. Okay? So no matter what I say I have a mole of, it means I have 6.022 times 10 to the 23rd particles or atoms or ions or molecules. Okay? It's a counting number like some of these other things are. Okay? If I say I have a pair of shoes, that means I have 2. If I have a pair of, I don't know, what else can I have a pair of? Doesn't mean it for glasses, though. I just realized that. A pair of glasses is just 1 glasses. Oh. Okay, pair. Let's take the pair out. Pair. No longer we're going to use that. Take it out. It doesn't know what we're talking about. That's true. A pair of pants. Good point. Okay? All right. So, the song kind of addressed this a little bit, but how big is a mole? Okay? So we're talking about a mole with really, really tiny things, like things you can't see. But if for things that you can see physically, you know, wrap your mind around, hold it, touch it, feel it in your hands. This just kind of gives you an idea of, everybody likes to talk about the money one. If you had a mole of dollar bills, you could spend $1 million a day every minute of your life, and you would never spend it all. Okay? If you had it says oranges, if you had a mole of oranges or anything else, and you continually counted it out at a rate of 1 orange per second, it would take about 4 million years for all the oranges to be counted, because those are big. Okay, it takes a lot of space. But atoms are really, really small. In the video and the song, it talked about holding a mole of sugar in your hand. Okay, because a mole of sugar is going to be 180 grams. Okay, if I have a mole of table salt, it would be only 58 grams, and I can hold that in my hand. Okay, and that's because atoms are so incredibly small, which is why we have such a large number to relate how many atoms or molecules are actually there. Okay. So, hopefully that kind of gives you an idea of how small atoms really are. So, here we go. Molar mass is the mass of 1 mole of a pure substance. The pure substance can be an element or a compound. The atomic mass is the mass of 1 atom of that, measured in AMUs. Okay? The atomic mass is also equal to 1 mole of the atoms. Okay? So, when we're talking about copper, we can say copper either has a molar mass of either 63.55 grams per mole, or we could say AMU. Okay? From here on out, after we've done atomic mass unit, and we did the Candium lab, we will now be using grams per mole, because we're going to use it as a conversion factor. We'll start that tomorrow. But it's grams per mole. That means like 63.55 grams for copper. It's always per 1 mole. Anytime you see a unit, like we did density and we did grams per milliliter, okay, that means per 1 milliliter, okay. If I did miles per hour, per 1 hour, centimeters per second, per 1 second, the per part is always 1 on the bottom. But for the mole, that's going to be very important, because when we start doing calculations with it later in the year, people like to try to change that on the bottom. Never change it. It's always 1 mole on the bottom, okay. All right, so how do we actually calculate it? First of all, you have to have the correct formula. Not going to be a problem for you in this unit because I haven't taught you how to do that yet. So you'll get the correct formula. Then you're going to look up the atomic mass of each element. We're going to round these to 2 decimal places, just like we did for AMU. Please use the periodic table that I gave you. The masses are already rounded to 2 decimal places, so there's not any confusion. Okay? And then you're going to multiply any mass of the subscripts and then add all the elements together. Okay? So in this case, I have sodium chloride. Sodium is 22.99. Chlorine is 35.45. Add them together, and your molar mass for sodium chloride is 58.44. Okay? So let's do 2 together before I turn you loose. Okay? Calcium phosphate is another example. They should be written as subscripts, and I don't know why they're not. Typo. Okay? So when you have subscripts in a formula, the subscripts only count for what comes right before it. So this 3 only goes for this calcium. Okay? This 4 only goes for this oxygen. However, looks like I made a smiley face. However, the 2 goes for everything inside of it, and you multiply inside. So I really have 2 phosphorus and 8 oxygen. Okay? And if you look at the way it's added up, that's what you do, is you add it up. Okay? So you multiply inside the subscripts, inside the parentheses, I mean. Okay? So everybody have your calculator ready. All right, so I have, find the molar mass of ammonium sulfate. Okay? So first of all, how many nitrogen do I have? 2. And someone look up what is the molar mass of nitrogen on your periodic table.
Gotcha.
14.01 plus
14.01.
how many hydrogen do I have? 8. Okay, what is the molar mass of hydrogen? 1.01. Here's where I want to caution you. A lot of people see that 1.01 and they think, oh, the 0.01 doesn't make that big of a difference, and they leave it out and just do 1. Okay, if you only have 1 or 2 hydrogen, it doesn't. But what if I have 18 hydrogen?
That does make sense.
Then it would be 18.18, right? I'd be dropping off almost 0.2 grams. Okay, so don't drop off the 0.01. Okay, and then I have 1 sulfur. What was the molar mass of sulfur?
32.07. Got it, guys.
Okay, and then how many oxygen do I have? And what is the molar mass of oxygen? 16. All right, everybody put that in your calculator, and let's see if I can get an agreement amongst you of what the answer is.
Gotcha.
And how many decimal places are we going to write down? 2. First one to get it, raise your hand.
Ooh, it's a race.
Yes,
84.17.
that is incorrect.
Oh, stucky.
Yes,
Is it 132.17?
yes it is. 132.17 grams per how many moles? 1. Thank you. That's why we're doing it together, to see if you get the right answer.
Oh, I put 22 instead of 2. That makes sense.
22 instead of 2?
For 2 times 14.01.
Oh, okay. Okay, now let's do the Cl2O7. So I have 2 chlorine, and what is the molar mass of chlorine?
35.45. 35.45.
Thank you. And then I have 7 oxygen times 16. All right. Tell me what you get. Look at him. You are fast today. What's that?
294.9.
Say that again.
294.9.
294.9?
182.9.
Ooh.
Oh, goodness.
Hold up. Mattel's got this.
182.9? That's what I remember it being.
182.9. Oh.
Okay, there seems to be our agreement.
Bang.
All right. Okay. So that's how you do molar mass. Very, very simple. Very, very simple. The biggest mistake that kids make, though, is instead of adding the masses for each element together, they multiply. If you do that, you're going to get a super large molar mass. You shouldn't get like super large. I mean, there's some that get into the 300, 400s, but you're not. You shouldn't get like a $10,000 gram per mole molar mass. That means you probably multiply them together, and then the subscripts only go for the element that comes right before it. Okay, so you have some homework over that, which we'll talk about here in a second.